Welcome to DHS Informatics. In this video, we are going to see the demonstration on fire detection using deep learning. We are inspired from the IEEE paper which is published in the year 2021 titled as Fire Detection Using Deep Transfer Learning on Surveillance Video. In DHS, we are going to develop a project with two techniques, one with Jupyter Notebook and another one with Flask. Jupyter Notebook is basically a backend and Flask is a front end. In Jupyter Notebook, we will load the data, we will do the pre-processing technique, we will train the model, test the model, and finally we will save the model. This is how the Jupyter Notebook look like. Here we are using three models. CNN, VGG16, RENSNet. I will show you one by one. This is the first model, that is CNN, Convolutional Neural Network. First we will import all the necessary libraries and we will load the data. Here we have two data sets, one is for testing and one is for training. Here we will analyze in the training data set how many labels are there. There are two labels, one is fire and one is no fire. After that we will plot one visualization, number of samples versus target. Fire, how many samples is consist of, no fire, how many samples is consist of. In pie chart we can clearly see that 50.66% of fire data set and 49.34% of non-fire data set. After that we will do the normalization here. This is how X train look like. These are the images. This is how the machine will read the images. And these are the target, Y train. After that, we will again display some images, X train. Now we will load the test data set. Till now training data set has been loaded. Now test data set has been loaded. In test data set, 32.35% of fire is there, fire images are there, and 67.65% of no fire images are there. After that we will do the normalization for test data set. This is how X test look like, and these are the Y test labels. No fire images, test data set. Splitting of the data set will be happened, Y train, X test, Y test. After that we will comes with the algorithm, that is convolutional neural network. Model building will be done. After model building, this is the model summary of CNN, and we will train our model. Here we have given 20 epochs to train our model. After that we will plot accuracy plot and loss plot graphs, and CNN model predictions are here. These are the prediction made by the model, and these are the true values. Now we will compare true values with the predicted values. In result analysis, here we are getting 75% of accuracy, and this is the classification report of CNN and confusion matrix of CNN. Finally, we will save this model. This is about convolutional neural network model. Now we are going with the second model, that is VGG16 model. Again we will import the necessary libraries. We will load the trained data set. We will plot the visualization for the trained data set. We will do the normalization, extrain images, after that their targets. These are the training data set images. After that we will do the same things for testing also. We will do the normalization for testing data set. This is how X test look like, and this is Y test, and these are the images of test data set. Then we will build the model here, VGG16 model. After building the model, this is the model summary, VGG16 model summary, and we will train the model. Here also we are using 20 epochs for training our model. After that we will plot accuracy graph and loss plot graphs, and this is the model prediction. We will compare this predicted value with the true value, and here we are getting 92.65% of accuracy for VGG16 model. This is the classification report of VGG16 model, and this is the confusion matrix. Finally, we will save this model. This is about VGG16 model. Next, we are going with ResNet 152 V2 model. This is the third model we are using in this project. Here we are importing again then all necessary libraries, and we are loading the data. First we will load the trained data set, number of samples versus target graph, and visualization using pie chart, as you can see here. And we will do the normalization for training data set, and this is how X train images look like, and this is Y train. These are the targets 0 and 1, fire, no fire. And these are some images from training data set. And here we are loading testing data set, which is also consists of two targets, fire, no fire. We will plot the visualization for testing data set. After that we will do the normalization for testing data set. This is how Y test, X test look like, and this is Y test, which is nothing but targets. These are some images from testing data set. After this we will build the model ResNet 152 V2. After building the model, this is the model summary. This is the model summary look like, and we will train our data with 20 epochs. After that we will plot loss, accuracy plot and loss plot. After that model prediction will be done. These are the values predicted by the model. We will compare with the true values, and here we are getting 98.53% of accuracy, which is more compared to other two models. This is the classification report of ResNet 152 V2, and this is the confusion matrix. Finally, we will save the model. This is about the backend part. We have trained 3 models. Now we are going with test model. We need to test that particular model, right? For that, here testing will be done. Here we are importing necessary libraries. ResNet 152 V2 has given more accuracy, that's why we are considering that particular model here. We have two labels, fire, no fire, and we have given input data, that is test file. Here we are doing normalization. This is our input image. The model should predict now, is this fire image or no fire image. The output will be class name 0, class label, that means fire, probability 99.99%. That means our model has predicted correctly the above image is a fire image. This is about the backend part. Now we will see how the front end will work. This is how the front end will look like. First we need to register. For that we need to give our name. We have to create one email. We need to register first. After registration, we need to log in with the same email ID and password. After once we log in, you can see here we should click on choose file. I will give some image like this one. I will upload this file and I will click on submit. Now it is saying this image is fire image. The model has predicted correctly. We will try with some more image which is no fire. Okay, I will upload this image. Submit. Now the model is saying no fire. The probability is 100%. This is about the front end part. This is about this project. The model has predicted correctly fire images and no fire images. In DHS Informatics, we are going to provide a project to the very reasonable price and help you until the last phase of your review. So that please contact us at 9845166723 or 988669241. We will also provide a quality report and we will help you with the installation and we will explain the entire code along with the PPTs. For more information, you can come into office or WhatsApp us. If you like this video, please like, comment and subscribe. Thank you for listening to the video.